Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 9 of lesson number 2, Is Matter Around Us Pure? So, as this is going to be the last part for the lesson, we are going to discuss about the matters, how they are further classified as. That is, we will be discussing about the elements and compounds, and then we have a short summary discussion and then few exercise questions. Like altogether there are 11 questions which we are going to discuss, right? So before I start with it, I want each one of you to please revise whatever note you have taken in your book, because that is very important for you to know. So please keep on revising whatever you have written or whatever notes you have taken in your book. I will be showing you the screen one by one, but before that, this is very important. I hope everyone had a quick glance through whatever you have written in your book. Now you need to revise it from the screen as well. So we have started this lesson, Is Matter Around Us Pure, by discussing on the classification of matter, where the most important thing that we studied was like everything around us. Okay, if you go in the market you will see like there are many things where they keep it on the pack that it's pure ghee, pure this, pure milk, pure curd and everything. So it means that whenever you see any purity which has been mentioned on the screen, like as you can see there are three different consumable items which have been shown. So in this case you should know pure means, scientifically it means that it is made up of only a single part of type of particle. It is not representing the purity of that substance. Okay, so I want you all to please go through the slide once. Sorry. So after this classification of matter, we discussed on what exactly mixtures are, right? So if anything around you is made up of more than one kind of pure substance, then we call it as a mixture, right? And here we have some of the characteristic properties of the mixtures as well, which have been given with few examples. So I want you all to please go through the slide quickly. Make sure you all are revising it well, because this is the last part for the lesson. After what is mixture, we have like types of mixtures, under which we have studied two different activities, right? So I want you all to please go through the slide as well once. Then we discussed on this activity 2.2 as well, and I want you all to please go through it properly. After this, we discussed on like what exactly a solution is. So I want you all to please go through it once, and like even we have information on the three different types of solutions, that is diluted solution, concentrated solution and saturated solution. And along with that, we have even information on solute and solvent as well, right? So I want you all to please go through it. Then we discussed on few of the examples. So I want you all to please go through it once. Then we discussed on the properties of solution. So I want you all to please go through it once. After this properties of solutions, the next thing that we have is concentration of solution, where we studied what are dilute solution, what are concentrated solution, and what exactly concentration of a solution is, right? So I want you all to please go through the slide as well now, as this is one of the most important like part for the lesson, because this is the last part where you are revising it for the last time, right? So make sure you're understanding each and everything. After this we discussed on this activity, so I want each one of you to please go through it activity, and like here the explanation part has not been given, right? But you should be able to explain it very well. What is the conclusion, what is the observation that you come up with, everything should be like you should be knowing in detail. Okay. Then we discussed on like the explanation on that activity, and we came up with, you can say, three methods of expressing the concentration of a solution. Okay, so I want you all to please go through the slide once very properly. This is an example that we have studied with respect to the same thing, right? So I want you all to please go through it properly, and I hope like next time when you're writing it, you will be able to like solve the question which has been given. Then we discussed on what exactly suspensions are. So please go through this slide because properties I have already told you in all the parts that properties of suspensions can be asked, not only the suspension part but even like properties of colloidal solutions, and so it can be asked for 2 to 3 marks. After this, like we have Tyndall effect to study. So I want you all to please go through this Tyndall effect. Then we studied on the properties of colloid. So I want you all to please go through this as well. I hope everyone is going through it. Then after this, here we have few of the examples of colloidal solution. Then we discussed on like separating the components of mixture, where we have studied all of the methods now, right? We have studied about evaporation, we have studied about centrifugation, separating funnel, sublimation, chromatography, distillation. We have studied all these six methods, right? How can we separate the component of mixture? So like we first studied about how can we obtain colored component, that is dye, from blue or a black ink, right? So we have studied that through an activity here, and this process we know it as evaporation process, right? After this we discussed on like how can we separate cream from milk, right? So for that we can separate the cream from milk through the process of centrifugation. Now what happens in centrifugation? The tube that you will like in which you will add the milk, like it is going to rotate at a very high speed. Okay, the RPM will be very high, because of which you will see that the cream will get separated from the milk. Okay. After this we discussed on like how can we separate a mixture of two immiscible liquids, right? So I just want you all to please go through this activity, and here we have the application of the separating funnel as well. Then we discussed on like how can we separate a mixture of salt and camphor, because it is difficult to separate those mixture, right? But now if we apply the process of sublimation over there, the process becomes much easier in that case, right? Then we discussed on like is the dye in black ink a single color or it is made up of many colors. So for that we have this chromatography technique to discuss, like, right? So through this chromatography technique we will be easily able to find out whether the black ink is made up of a single color or it's made up of many colors altogether. Then after this chromatography technique, we discussed on like how can we separate a mixture of two miscible liquids, right? So we can do that through distillation process, and apart from this distillation, simple distillation, we have even discussed fractional distillation if you all remember. I hope you all are going through, and the figure which has been given, like which has been given for all the six different types of, you can say, separation techniques that we have studied. While you write about it, you have to make sure you are drawing the figures as well. That is also very important. Okay. After this, we discussed on this distillation, simple distillation, and lastly, we had fractional distillation, right? So I want you all to please go through it. Then after this, we discussed on how can we obtain different gases from air, because we know air is a mixture of different gases. So now the question is, how can we separate those gases? So that is even possible, right? So I just want you all to go through this as well once. Then after this, we discussed about the separation of the components, how exactly it has been done under air pressure, right? And this is done through fractional distillation column over here. Then we discussed on how can we obtain pure copper sulfate from an impure sample. Now this is also very important, and we can do that through the process of crystallization. So crystallization is the last technique that we have studied, I guess, right? Because after that we had this physical and chemical change. So I just want you all to go through this activity once. Then we discussed more about this crystallization technique over here. And lastly, we had the like application which has been given, right? So I want you all to please go through it once. Then we discussed on physical and chemical changes in detail with different examples. So I want you all to please go through this slide about physical and chemical changes. After this physical and chemical changes, like here we have more information about them, and always remember, in physical change no new substance will be formed, but in chemical change you will see that a new substance will get formed. Okay, so you should be even knowing to distinguish them. That is again very important. Okay, so I just introduced you all about the types of pure substances in the last class, where I just told you that substances can be classified either as elements or compounds, right? So we are going to discuss about elements in detail now. So see, Robert Boyle, he was the first scientist to use the term element in 1661. So he's the first person to use this term element. Then we have Antony Laurent Lavoisier from 1743 to 1904. He was a French chemist, and he was the first person to establish an experimentally useful definition of an element, where Antony Lavoisier, he defined an element as a basic form of matter that cannot be broken down into simpler substance by chemical reaction. Now the definition of element is very important over here. What they have said, what Lavoisier have stated, that element is something which is like a basic form of matter which cannot be divided or broken down further by chemical reactions, right? After this, like they have stated that elements can be normally divided into metals, non-metals and metalloids. Now this is also very important. You should be knowing the further division of elements. So elements can be further divided into three different types, which includes metals, non-metals and metalloids. But before I proceed further with the metals part, I want you all to please write the definition of elements and what elements are further classified into. So here we have some of the properties of metals which have been given. Metals have luster. Now, having luster means that metals are shiny in nature. Like if I tell you about the example of gold and silver, right? They are shiny. So that property of the metal is called as luster. Okay. Then they have a silvery gray or golden yellow color which can conduct heat and electricity. So metals are good conductor of heat and electricity. Okay. And the appearance is like they are going to be silvery gray or golden yellow in color. They can conduct heat and electricity. They are ductile means like you can convert the metals into thin wire, and ductility is one of the property. Apart from that, we have one more property as malleability. Now malleability means while you strike the metal, you can convert the metal into thin sheet. Okay, that is known as malleability. Then sonority, it means like they produce a ringing sound when you struck them. Okay, and examples of metals are gold, silver, copper, iron, sodium, potassium. And see here we have some of the exceptional cases which are even been given, that mercury is the only metal that is liquid at room temperature. Rest all the metals are going to be solid. Okay, and non-metals usually show all of the following properties, where you will see non-metals will have variety of colors. They are poor conductor of heat and electricity. They are not lustrous. They are non-ductile, non-sonorous, non-malleable. Whatever properties that you have studied for metal, complete opposite is of non-metal. Okay, and now there are some substances which are going to have the properties of metal as well as the properties of non-metal. So such kind of substances are called as metalloids. So some elements have intermediate properties between those of metals and non-metals. So they are called as metalloids, and the example of metalloids include boron, silicon and germanium. Okay. I want each one of you to please take a note of it in your book. After this, now the next thing that we have is about compounds. So see, Compound is a substance which is composed of two or more elements chemically combined with one another in a fixed proportion. Now, when two or more elements are getting chemically combined with each other in a fixed proportion, we call that substances as compound. But it should be in fixed proportion, and you should be knowing that fixed proportion. Getting it, everyone? So I want you all to please take the definition of compound in your book. After this, we have this activity to discuss. See, divide the class in two groups, and here we have to give 5 grams of iron fillings and 3 grams of copper sulfur powder in a china dish to both the groups. Okay. Now group 1 is going to mix and crush the iron filling and sulfur powder, and group 2 is going to mix and crush the iron filling and the sulfur powder. Okay, then hit this mixture strongly till it becomes red hot, and after that, once you see that the mixture has become red hot, you have to remove it from the flame and let it cool. Okay, after that, both the groups are going to check for magnetism in the material which has been obtained by bringing a magnet near the material, and you have to check it whether it is getting attracted towards the magnet or not. Okay, and once you are done with it, you need to compare the texture and the color of the material which has been obtained by the group, and we can do it by adding carbon disulfide to one part of the material which has been obtained. After adding carbon disulfide, we have to stir it well and filter it out. Okay, and then we need to add dilute sulfuric acid or dilute hydrochloric acid to the other part of it. Okay, so this is the activity, and you have to check what exactly happens. So if you get time, you can just have a look on the reactions. Okay. Now we have the difference between mixtures and compounds which have been given. See, elements or compounds just mix together to form a mixture, and no new compound has been formed. So this is the definition of mixture. Okay. Whereas in compounds, the elements are going to react with each other and they are going to form a new compound. Now always remember that mixture is going to have variable composition. The composition is not going to be fixed over here. But as in compounds, the composition of each substance in compound is going to be fixed. Okay. Then a mixture shows the property of constituent substances, and compounds, here you will have that a new substance will be totally formed over here, and that new substance will have different properties, okay, as compared to mixture. Then we have the fourth point in mixture as the constituents can be separated fairly by physical method, whereas in compound we can separate the constituents by chemical or electrochemical reaction. How can we separate it? By chemical or electrochemical reactions. So I want you all to please take a note of this in your book regarding mixtures and compounds. I hope everyone is writing mixtures and compounds. After this, now we have C, the matter which exists in three different states, solid, liquid and gas, can be further classified as pure substance and mixture. How it can be classified as pure substance and mixtures? Now the pure substance can be further classified as elements and compounds. So see, elements cannot be broken down into simpler substance, and the example of it is copper, oxygen, iron, hydrogen and mercury. Okay, and when it comes to compounds, compounds are going to have fixed composition, and we can even break it down by like it can be broken down into elements by chemical or electrochemical reaction, and the example of compounds include water, methane, sugar, salt and all. Okay. Then when it comes to mixtures, now mixtures do not have any fixed composition, right? So mixtures can be further classified as homogeneous mixture and heterogeneous mixtures. Now always remember that homogeneous mixtures are always going to be like you are going to have uniform composition, and heterogeneous mixtures are going to have non-uniform composition. Okay, then the example of homogeneous composition includes sugar and water, salt in water, sulfur in carbon disulfide, then water in alcohol. These are all examples of homogeneous mixture. And heterogeneous mixtures include sand, sand and salt, sugar and salt, water and oil. These are all examples of heterogeneous mixtures. Okay, so I just want you all to please go through it once as we have completed with the lesson now. After this, now we have the summary discussion in detail. So see, here we have studied that a mixture contains more than one substance which will be mixed in any proportion, right? And we can separate the mixtures into pure substances by using any one of the separation techniques. We have studied altogether 6 separation techniques till now, right? Then we studied about solution. That solution is a homogeneous mixture of two or more substances, and the major component of solution is going to be solvent and the minor component will be the solute. And when it comes to concentration of solution, how will you define it? It is the amount of solute present per unit volume or per unit mass of the solution. Okay, so over here the materials which are insoluble in a solvent, they are going to have particles that are visible to naked eye, and these particles which are visible to us, they are going to form a suspension. And always know that suspension is a heterogeneous mixture, and along with suspension, colloids are also heterogeneous mixture, and you will find out that suspensions were easily visible to us, right? But colloid particles are too small and like can to be seen through our naked eye, but it is big enough to scatter light. That is why colloids have major usefulness in the industries and daily life. Okay, so after getting dispersed, like the particles of colloids are called as can be in dispersed phase, and the medium in which they have been distributed, we know it as dispersion medium. Okay, then we studied about pure substances, that they can either be classified as elements or compounds, where element is a form of matter which cannot be broken down by chemical reaction, right? And compound is a substance which is made up of two or more different types of elements. Here the two or more types of elements are combined in fixed proportion, right? That is why the properties of compound are different from its constituent element, whereas when we compare it with mixtures show the properties of its constituent element or compound. Got the thing? Like this is what we have studied so far in the lesson, right? Is matter around us pure? And I hope every one of you are clear with this part, and you are even clear with the summary discussion that we had just now. Now here we have few of the exercise questions which have been given over here, where the first question that they have given is, which separation technique will you apply for separation of following? Now for separation of sodium chloride from its solution in water, which separation technique will you apply? So in water, sodium chloride in its solution can be separated through the process of evaporation, right? Then the second mixture that we have is ammonium chloride from a mixture containing sodium chloride and ammonium chloride. So this can be separated by sublimation process, right? Then the third one that we have is small pieces of metal in engine oil of a car. This can be done by filtration technique. Then different pigments from an extract of flower petal. This can be done through chromatography technique, right? Then butter from curd. Now if you have to separate the butter from curd, in that case we can have centrifugation technique, right? Then oil from water. For this we can have what can you use? Because here we have to, you can use a funnel over here and do the separation. Okay, then tea leaves from tea can be separated by simple filtration technique. Iron beans from the sand can be separated by magnetism technique, right? Then wheat grains from husk can be separated by either sedimentation or winnowing process. Then lastly that we have is fine mud particles which are suspended in water. So here we can have sedimentation technique again which can be applied. Okay. Now after this we have the second question, where you need to write the steps you would use for making tea and use the word solution, solvent, solute, dissolve, soluble, insoluble, filtrate and residue. So like how can you write it? Into a vessel add a cup of milk which is the solvent and supply it with heat. Okay, after that add tea powder or tea leaves to the boiling milk which act as a solute and continue heating it. Then third point you can write that the solute, which is the tea powder, is going to remain insoluble in the milk, right? And you have to like boil it continuously, and after that we need to add some sugar to the boiling solution while stirring. So now sugar is a solute but is soluble in the solvent, right? And continuous stirring has been done over here so that the sugar can get dissolved completely in the tea solution, and this is how, using all the words, you have to write the steps which has been used for making tea. Okay, now the third question that we have is, Pragya tested the solubility of three different substances at different temperature and collected the data as given. So now what mass of potassium nitrate would be needed to produce a saturated solution of potassium nitrate in 50 grams of water at 313 Kelvin? So here like you can do it 62, because the mass of potassium chloride in 50 grams of water at 313. So the solubility, if you can see, of potassium nitrate that has been given is 62, right? So 62 into 50 divide by 100 and you will get the answer as 31 grams. Okay. Then the second question is, Pragya makes a saturated solution of potassium chloride in water at 353 Kelvin and leaves the solution to cool at room temperature. What would she observe as the solution cools? Explain. So here what she can observe is like crystals of potassium chloride which will be surpassed. Okay. So crystals of potassium chloride can be seen over here. Then third is, find the solubility of each salt at 293 Kelvin. Which salt has the highest solubility at this temperature? So when you calculate it properly, you will get that ammonium chloride will have the highest solubility. Okay. Then what is the effect of change of temperature on solubility of salt? So you can see that because the solubility of the salt is dependent upon temperature and it increases with increase in temperature, right? So with this we can infer that when a salt arrives at its saturation point, there is going to be like propensity to develop more salt over there, because of which the temperature of the solution will increase. Okay. Now we have the fourth question as explain the following giving example. Saturated solution, pure substance, colloid and suspension. So these are all direct question which I think you can write it. Now classify each of the following as a homogeneous or heterogeneous mixture. So soda water is a homogeneous mixture. Wood is a heterogeneous mixture. Air is a homogeneous mixture. Soil is a heterogeneous mixture. Vinegar is a homogeneous mixture. Filtered tea again is a homogeneous mixture. Got it? So there are 4 homogeneous mixture, whereas wood and soil are heterogeneous mixture from this. Okay. Now the next question that we have is, how would you confirm that a colorless liquid given to you is pure water? So we can confirm it like by boiling it. So if it boils at 100 degrees Celsius, we can call it to be pure. But if there is increase or decrease in the boiling point, we can say that the water has impurities in it and we can conclude that it is not pure. Okay. Then we have like, which of the following materials falls in the category of pure substance? So we can have iron, ice, hydrochloric acid, calcium oxide and mercury. These 5 things can be considered as pure substance, rest all are not. Okay. Then we have this, identify the solution among the following mixture. So over here, seawater, air and soda water. These are all mixtures, rest all of them are not these are all solutions, rest of them are not solutions. Okay. Then ninth one we have, that is, which of the following will show Tyndall effect. So here you should know that Tyndall effect is exhibited only by milk and starch solution. Rest all of them will not show this Tyndall effect. Okay. Then 10th one is, classify the following into elements, compounds and mixtures. So sodium, silver, tin and silicon, these are all elements. Calcium carbonate, calcium dioxide and methane, these are all compounds. And rest everything like soil, sugar solution, coal, air, blood, soap, rest everything is a mixture. Okay. Then now you have to tell me which of the following are chemical changes. So chemical changes like growth of plant is a chemical change, rusting of iron is a chemical change, cooking of food is a chemical change, and lastly digestion of food and burning of candle. So these 5 are chemical changes, rest all of them are physical changes. Okay. So here we complete with this lesson, is matter around us pure, and I hope you're clear with whatever we have discussed so far in this lesson. So you'll be complete with it, and in the next part I will be like starting with a new lesson, the next lesson. So everyone, make sure you all are attempting all the question and writing it down in your book as well. And if you have any doubt, please reach out to us. Okay, thank you everyone.